Okay. It's frozen. You can't see that. Thank you. Okay. Review packet 4. We are on the middle of the second page. We're starting the word problems. Megan, could you grab the notes or lights, please? Okay. So as I look at word problems, we did these last year. Word problems are always annoying. I get that. However, I tried to give you a good step-by-step way to get these done. Okay. So let's go and look at number 3 because it's the trickiest of the 3 word problems. Okay, this is a system. System means what? System of equations means what? We did them on the front page. So flip to the front page. Do you have yours somewhere, Will? Yes, 2 linear equations. Were you here Friday? Were you here Friday?
Oh, we're still doing them?
Yep, we're finishing the number 4. Yep, you're good. Yeah, so a system is 2 equations, so we are going to have 2 equations for these. So let's look at number 3. When I read a story problem, the first thing I want to look for is what are they asking for? Nicole has a collection of 29 nickels and dimes that is worth $2.30. How many of each does she have? What am I looking for? Yes, Zach.
How many of each you got?
Which, a little more specific. By each you mean a little more specific. Nickels and dimes. So let's go ahead and we're going to let n be the number of nickels. Now be careful, it's not the price, it's the number because I want to know how many of each. So I want to know the number of nickels, which I'm going to let represent n. Could use x and y, doesn't matter. And d is going to be the number of dimes. Look for what they're asking for, and that will help you figure out what your variables are. So it is how many of each. So number of nickels, number of dimes. Any questions? Now read the first sentence. Nicole has a collection of 29 nickels and dimes worth $2.30. As I read this, what information do they give me?
She has 29 nickels?
Read it. She has 29, has a collection of 29 nickels and dimes. So 29 is actually...
Each. Like both combined, right?
Yes, both combined. So it's kind of hard to read, but 29 is the total number of nickels and dimes. So think about this.
She meant 29 nickels.
Yeah, it's hard to read, but that's total. So 29 nickels and dimes. So if 29 is a total, what do I always do to find the total of something? Don't overthink this. If I want to find the total of something, I do what with those 2 things? Add them. So anytime we're looking for a total, I'm going to add things together. So 2 things added, give me a total of 29. Common sense, you know that. 2 things, to find the total, you add 2 things together. Now, that is the number of nickels and dimes. So how do I represent that using my variables? Yes? Be careful, this is tricky. He said 0.05 n and 0.1 d. Now be careful. This is dealing with the number of nickels and dimes, not the money. It's dealing with the number of nickels and dimes. So it's just going to be n plus d. Yeah, that's tricky. So a lot of you have kind of the right idea, except 29 is dealing with the total number of nickels and dimes. So it's just the number of nickels plus the number of dimes. Does that make sense, Colton? The second total is dealing with how much money. The second total they give me is what? Yep. That is dealing with how much money. So now I have to worry about how much a nickel costs and how much a dime costs. That's where that 0.05. So it's 0.05 n. Why is it not 0.5? That would be 50 cents. Good. So 0.05. Each nickel is 5 cents. And then it's going to be plus. How much does each dime cost? 0.1 or 0.10. You don't really need the 0 at the end. It doesn't matter. Finish? Your question. Oh, okay. Can you just bring your Chromebook? I'll take it and then just bring your Chromebook in here. Okay, so we have my two equations, and we talked about yesterday, or on Friday, substitution or elimination. What are we thinking on this one? Let's do elimination. Substitution wouldn't be too bad, but I don't have any equation n equals or d equals. You could do something to the top, but we could also do elimination. So let's think about this. If I want to eliminate either the n or the d, which one do I want to eliminate? Okay, so as I look at the d, I have 0.1 in the bottom, so I need what on the top equation to cancel out 0.1 when I add them? Negative. So I'm going to take a negative 0.1. John, keep your head up, please. I'm going to take a negative 0.1 and distribute it through the top. Now, it's decimals. Whoop-de-doo. Use the calculator. It's the same thing, though. Okay? So if I take my top equation and I multiply by negative 0.1, what does my top equation look like? Negative 0.1 n, because it's 0.1, not just 1, so you need the 0.1 there. Minus 0.1 d, and what is negative 0.1 times 29? Use a calculator. I don't know off the top of my head. So negative 0.1 times 29. So I'm going to do it real quick. I literally put the calculators like an inch from your face, so I think we all can grab one. What is it? Negative 2.9. Yep, negative 2.9. That's the top equation. The bottom equation doesn't change. Okay, now we're working with decimals. Use a calculator. I don't expect you to know, I mean, you have done it in your head before, but I don't care if you use a calculator. Now, we notice the d's will cancel. The d's will only cancel when I do what with both equations? Add them. You have to add them together. So what is negative 0.1 plus 0.05? Use a calculator. What is it? Negative 0.1, plug it in your calculator. Negative 0.1 plus 0.05. Negative 0.05 n. I have a negative 0.1 and a positive 0.1, so the d's cancel. Equals, what is negative 2.9 plus 2.3? Plug it in your calculator. What is it? Nope, negative 2.9 plus 2.3. Negative 0.6, yep. So I get decimals are weird and you don't use them a lot, but you use your calculator. And then how do I get n? Divide by negative 0.05. Again, I don't expect you to know this. Use a calculator. Negative 0.6 divided by negative 0.05. What is it? 12. Nope. Negative 0.6 divided by negative 0.05. Now, she said negative 12, which brings up a good point. Would it make sense that I would have negative 12 for n? What does n represent? The number of nickels. You can't have a negative number of nickels. So you could not get a negative for n. No, you can't. Yeah, but you don't have negative. Like you can't. Whatever. We're not going down the same thing. Okay, now, have I answered the question? No. How many of each? So I know she has 12 nickels. How do I find how many dimes? Okay, what's the easiest equation to plug it into? The top one, because it's just n plus d equals 29. So 12 plus d equals 29. Turn on the top tray, if you don't mind. Thank you. So 12 plus d, use the top one. It doesn't matter which one, but I would use the one, the original one that doesn't have decimals. So 12 plus d equals 29. How do I find d? Subtract 12. D equals 27. So there are 12 nickels. Just kidding. 17. 17. So 17 nickels and 17 dimes and 12 nickels. Any questions on that? Okay. That's the hardest one. Do you want me to get one of the story problems set up for you?
Yeah.
Okay. 1 or 2?
2.
I'm not going to go through it all the way, but I'll set it up because I'm feeling nice today.
Which one's harder?
I don't know. Let's do 2. Okay, so I'm going to set this up. I'm not going to go through all the work, but I'm just going to set this up. Reserve tickets for the football game cost $4 each, and general admission cost $3 each. After the game was over, it was found that 1,787 total tickets were sold, and $5,792 was made. Find the number of each sold. Read what they are looking for. What are they looking for? Okay, and when I say each, what do I mean?
Ticket.
No, more specific. More specific. Read it.
Game.
Read it. What 2 types of tickets do I have?
General.
General and?
I don't know.
Keep reading. Keep reading.
It's the same thing.
Nope. Keep reading. I have 2 different types of tickets. Reserved. Reserved seats cost $4 and general admission cost $3. So I'm going to let R.
What's the difference?
Reserved would be nicer seats. Closer, probably. Reserved is the R is the number of reserved. Listen up, guys. R is the number of reserved. Now it's asking find the number. So R is the number of reserved. I'm going to let G be the number of general.
Huh?
So I have reserved seats cost $4 and general seats cost $3. So those are my 2 types of tickets. Let's set it up real quick. Look for your 2 totals. What's one total they give me? 1787. What does 1,787 represent?
Sold tickets.
The total number of tickets sold. So how do I represent the total number of tickets sold? Perfect. It is R plus G. This is not dealing with money. So I don't have 4R and 3G because I'm not dealing with money. It's the total number of tickets was 1,787. The second total they give me is what? 92. So 5,792 is dealing with the amount of money. So I have to do what? Nope. Because 4 plus 3 means I sell 1. Yep. Because if it was just 4 plus 3, that would be you'd sell 1 reserved and 1 general. 4R plus 3G.
Where do you get those from?
Because it costs $4 for each reserve ticket, and it costs $3 for each general admission ticket. And I'm going to have you finish it from there, but that helps you get it set up. And I would probably do elimination. Big numbers, use a calculator, but you can do it. Okay, let's look at a couple on the back. The back will be easier. 95% of it is all review from what we did last week. But okay, now I'm graphing linear inequalities. This is different than what we did last week. Last week we did linear equations. What's the difference between linear equations and linear inequalities?
You shade.
You shade. Good. I'll let you spin the wheel at the end. Remind me. You shade, and what else is different?
Lines.
More specific. Yes, dotted or solid line. She stole it from you. Let me remind you, you can spin the wheel at the end. So you too. So that's the difference. You graph it the exact way, same way. Slope, y-intercept, blah, blah, blah. You have to check if it's dashed or full. You have to check which way to shade. Those are not hard things to do. So let me just kind of refresh. Okay, let's choose number 2 because it is the hardest. Why is number 2 harder than number 1? It is not solved for y. So let's take number 2. I'm going to do the harder one with you. And we are going to solve this for y. Because once I solve it for y, like I did last week, I can look for the y-intercept and put a point. Then I can do rise over run with the slope and do other things. But that's how we get the line. Well, the other 2 you don't really have much work. But well, you can flip it on the whatever. I don't care if you get a piece of paper and staple, whatever. Okay, let's solve this for y. What do we do first? Subtract the x. I want to get y alone, so I start furthest away. That's going to subtract the x. You could do it that way, but subtracting x is finished. Do you need to use decimals?
Yeah.
Okay, that's fine.
Cooler version.
Okay, So if I subtract x, I have negative 2y. Do not forget the negative in front. Listen up, guys. And then we have 8 minus x. We cannot combine those, so they stay there.
That's so cool.
How do I get y alone? Divide by negative 2. Now, when I divide by negative 2, it's an inequality. So it's going to be y is...
Less than equal to.
No.
Or more than equal to.
Greater than. I divide an inequality by a negative. You switch the direction. Y is greater than or equal to negative 4. 8 divided by negative 2. Then what's the negative 1 over negative 2? Yep, positive. Because it's negative over negative, and then 1 over 2, so positive 1/2 x.
Where'd you get this 4 from?
Because 8 divided by negative 2. Okay. Any other questions?
No.
Okay, let's graph this. What do I graph first?
The 4.
How do I graph a y-intercept of negative 4?
Down 4.
Put a point. So down 4, put a point. How do I get the next point?
You go up 1, go right.
Yep. My slope is a positive 1/2, so my line should be going uphill.
So right.
Excuse me.
Dashed or full. Full, because it's greater than or equal to. So it's a full. Doesn't have to be a perfectly straight line. Now, do I dash above the line or below the line?
Shade, you mean?
That's what I meant, yes.
Above.
Y, I know. Y is greater than. So if y is greater than, you shade above it. If y is less than, you shade below it. So I shade above that, and that's your answer. Exactly like we did last week. Just turn the top tray. Thank you. Except we have shading and dashed in full line. Okay. Any questions on that? I'm going to do one more. I'm going to do one of the 4 on the bottom. I'm not doing 4 because it's easier. 3? Let's look at 3. 3 is the hardest. Okay, let's look at 3. 3 is the hardest because they're not in slope-intercept form. They're in standard form. So you're going to have to do work to get y alone. So I'm going to do 3 with you because it takes the most work.
Can't you just do it?
Huh? No, we're not. We're graphing it. We're not trying to solve. We're just graphing it. So let's take my top equation. 4x plus y is greater than or equal to 4. You are doing the same thing we just did, except you do it twice. That's the only thing different with these. How do I solve this top inequality for y?
Wait, how do we know?
Up here, you said? Is that what you're asking about?
What?
If y is greater than, you shade above it. If y is less than, you shade below it. Is that what you're asking? So we need to get y alone, and then you can see how to shade it. Okay, how do we get y alone? Top inequality.
Divide it.
Subtract 4x. Yep.
Older than you.
So I have y is greater than or equal to, John, keep your head up, please. Y is greater than or equal to 4 minus 4x. So y is alone. There was not a number in front of y, so I didn't have to divide by anything. If I graph this, what do I do first? Go to 4 on the y-intercept. That's the number not with x. So I go up 4, positive 4. How do I find the next point?
Almost down 4, right 1.
I can go down 4, right 1, because it's a negative 4 over 1, or I can go up 4, left 1, whatever works. So you can do both, it doesn't matter. My slope is a negative 4, my line should be going downhill. Dashed or full? Full. Because it's greater than or equal to, so it's a full line. Carter, y is greater than or equal to, so I shade which way? Above it. Now this one's kind of hard. You're right. Okay.
What?
Yes. Where are we stuck at? You're good?
Y doing 4 minus 4.
Yes.
So your y-intercept is 4.
Yep.
Okay.
No, you're good. You go up 4, and the slope is negative 4 over 1, so down 4, right
I
1.
didn't know why you had 1.
No, you're good. Interrupt me. That's what I'm here for. Okay. Shade above it, which will be on this side. So don't shade it super dark, because I'm going to have another inequality over top of it. Then we're going to look at the second one. Same thing, you just do it twice. Okay. Let's look at the bottom one. 3x minus 2y is greater than 14. Okay, how do I solve this for y?
Minus 3x.
Minus 3x, because there's no sign in front, so we assume it's positive. Don't forget the negative with the y. So negative 2y is greater than 14 minus 3x. Please stop me if you need help.
-2.
Yep, divide by the negative 2.
Less than.
Perfect. When you divide the inequality by a negative, it becomes y is less than
Y is less than
14 divided by negative 2,
-7.
and then negative 3 over negative 2.
It's a fraction.
It is a fraction, yes. It's what type of fraction?
It's -3/2x.
Negative over a negative, so positive 3 over 2x. I know, I'm just making sure we know that. Positive 3 over 2. Y-intercept? -7. So go down 7. Put a point. Slope? Up 3, right 2.
Is it dashed?
Is it dashed?
No, yeah.
Yes. Y is just less than. There's a little line underneath, so it's a dashed line. And then I need to know if it's shaded above or below. I'm ignoring the first inequality. I'm just worried about the second one.
Is it shaded below?
Y is less than, so I look at my second one and I shade below it. We ignore the first
A
one.
real dark area, right?
Yes. So we are looking for where the shadings overlap, which is kind of this triangle on the bottom right. So shade it darker. So any point in that double shaded area works for both of these inequalities. Do you remember this?
Yeah.
Okay, it's just like linear equations, except a few things added here and there. Okay, so the homework will be to finish this packet, so you should have some good examples to look at. Tomorrow, this is the last packet, so we should